Good afternoon. I'm glad you're here. A little disappointed on the turnout, but for the first year, that's a good thing. This is my first year here at the ARC Forum. To give you an idea, I'm the Director of Energy and Utilities at Purdue University, and I've heard all about the Purdue model and the industry and the manufacturing industry. Our energy and utilities modeling has nothing to do with that. But I am taking names of people who don't like the Purdue model and take it back to the academics that developed that model. I'm going to go through some slides here. There's only about 10, maybe 12. We looked at energy and utilities at Purdue a little differently than a lot of organizations. Purdue created this department to get a grasp on what are we spending on utilities, how are we managing the assets, what can we do better as an institution, and we're pretty much a standalone entity out there. When we look at energy, my department takes it from the actual procurement of the raw energy source, coal, oil, gas, electricity, baseload from the utility companies. We also have production assets. We generate 40 megawatts of electricity, or capacity, we have 40 megawatts. We have 800,000 pounds of steam, 650 PSI, we're bottoming cycle. We have 36,000 tons of chilled water. So we produce all of that on our campus. We peak at about 58 megawatts. We also produce our own domestic water, or drinking water, and water for our power generation facilities and chilled water systems. We also manage all of the distribution systems. So where the Duke Energies of the world have their transmission grids and local distribution, we handle all the distribution of electricity, steam, chilled water, domestic water on campus. So we're producing it, we're pushing it out to the building, and we also manage all of the building control systems at the room level. We are the owner of the BAS, BMS systems, whatever you want to call it initial-wise, and we can control set point temperatures, turning on and off of equipment and everything else. And at the very end of this entire arc, we apportion it. We create billing, we create costing for the different buildings, structures, departments, however you want to piece it out. So in essence, we are like an electric utility company, only we handle electric, steam, chilled water, and domestic water. The only thing we don't manage is wastewater treatment. We do manage the storm and sanitary sewers that are on the campus. So we really have a lot of responsibility, but that format, that business model, established the ability for us to look across that arc, where are we spending money and where can we reduce our costs? And our president is a big fan of student affordability. So if we cut dollars, he's avoiding raising tuition rates, raising student housing rates, fees. He wants to make it affordable. And today, Purdue's still $10,000 a year for an in-state Indiana resident to go to Purdue University. Quite a deal in the world. There you go. So the question is, why do we want to look at all those things, including the building? Well, the U.S. Federal Facilities Council said, you know, you're spending 5% putting up a building. And in the life cycle of that building, you're spending 95% of the dollars. So the first thing people look at is, oh my goodness, look how expensive this building is going to be. And yet, that's not where we're spending the money. And a lot of that percentage, depending on who you talk to, 35% of that 95% can be your energy. Now, it varies from state to state, region to region, locations. Downtown New York City, energy is expensive, really expensive. But that's what we're focusing on, is not the 5% at the beginning, but the 95%. And if we focus on how we're using the 95%, that drives us right back into the 5% to make sure whatever you put in, even though it may cost a little more, can reduce the aggregate 95% of the costs of ownership. That requires a lot of rethinking by engineers, consultants, and senior leaders. Oops. So in order to do this, we looked at all sorts of very detailed modeling, very detailed fault detection diagnostics, and I worked with Iconics at a different university to implement that and have that roll out. And what I looked at was, we're getting too granular too quick for institutions that are too stuck in years ago. There's cultural changes that have to occur. And you can't make light year jumps without bringing all the people along, otherwise you're not going to enforce it. So I looked at it and said, we're going to set up a different one, and we had a great partner with Iconics. We're going to collect data from our BAS systems, from our meter management platforms. We have Siemens and ALC. Each one has about 100 buildings. We have a little over 200 buildings on the campus. How do I get that data when I have control companies that don't want to talk to each other? Hence, we're an advocate and a proponent of open protocols, things of that nature, to be able to share that data. In the past, years ago, I was simply told, we're not going to give you the data in a format that you can automatically integrate it with a different spreadsheet from a different vendor. We're not going to give you the ones and zeros that you own to line up with somebody else's ones and zeros, which was really frustrating. So we do workarounds. So we collect it, we put a gateway server device. We used an existing platform that we were able to drop in this gateway server device. On campus, we created a very secure VLAN network that runs on an IT backbone, but separated from the public domain completely without any crosstalk or cross-traffic. We are not connected, and if you want to get into our BAS system, you got to plug in to the fiber at a port that we have along the campus. And access is restricted, 3-tier authentication. Plus, if your IP address, your device isn't recognized, you won't even get a response back from our network. All that will happen is an alarm bell goes off saying somebody tried to access at this location in this building, somebody ought to go take a look at it. And that's the IT security people. So we collect all that data to the gateway server, and then because Purdue has done some research computing in the cloud, we utilize that proven technology pathway that's secure to push the data from our server on campus up to the cloud, where we use an Iconics-based server with Iconics software and packaging that we have in order to do some of the data analytics. But notice it's a one-way arrow. And it's a one-way arrow simply because we're not interested in people coming back into our control system. We're trying to keep people out. The cybersecurity element, I think we're quite a bit further ahead than many of my colleagues in the university world, at least they tell me I am. So our security is pretty good. We've gone down to the level where we are truly air-gapped in our production facilities. And I mean air-gapped as in there are no communications going out of our power plant to anywhere, as in we know all the ports and devices connected, as in it's hardwired. If you want to get into it, you're going to have to come in through the gates and the guards that we have. And then once we get it up there, what are we going to do with that? How are we going to use that? And I put out, there's a bunch of different areas that we can use this information, this data, if we can present it in a format that creates value to people who are going to look at it. So we're monitoring, and we started out doing steam, condensate, flow, temperature, and chilled water, flow, ton hours, and delta T on the temperature. We started out with 2. The implementation process in conjunction with Iconics went so fast and so good that we already are implementing steam flow, because steam going into building does not necessarily come all back in condensate. We also are doing electricity, and we're doing domestic water. So we're in the process of putting all of our utilities into this platform. But in steam condensate as an example, when we set parameters, some key performance indicators or operating performance indicators. I think steam condensate should never be above 150 degrees coming out of a building. Now, we can argue, we can debate that. A lot of my friends and colleagues say, well, it's between 140 and 160. There are all sorts of things, but it should never be above somewhere in that range. I set 150. If it's above 150, I'm not getting the heat value out of the steam I'm putting into the building. It's being transferred into my condensate, and the question is why? And that usually relates to performance issues on steam traps, steam heat exchangers, a whole series. And if I'm wasting that energy at that one building, how many days am I wasting that energy? So now from a metric standpoint, how many days are you on the list? And why? And then the second thing is we can calculate what the cumulative cost of that wasted energy is. In the past, nobody'd be looking at steam condensate temperature unless your condensate pump burned up because it was running at 200 degrees and the seals burned out. We are creating a transparency and a sharing of the data across the spectrum within the operation and maintenance people, the boots on the grounds. And that creates an accountability challenge, and that creates a culture change. So as we move in that direction, we need to bring all of these old school people, that some of them who have been there 30 years, into this new era that says, you have a problem with the building. And I can tell you, it doesn't matter on any campus I could go, there are people that to solve the banging of the pipe in a room will go in and take the guts out of a steam trap. Because you know what? The pipes don't bang because the steam's going right into the condensate. And now I've got a system where I have a steam pressurized condensate system. It's safety, it's health concerns, it's equipment damage. So now we can say, all right, here's where we're at, and we can send that list through that platform that we have automatically by an email to the managers and crew chiefs saying, here's how your buildings are performing. Here's where you need to prioritize some of your work. So everybody loves ROIs. Well, I'm not investing anything because I have staff that are already paid for. I might be spending some on materials, but usually if it breaks, it's part of their repair budget anyways. So now I look at it, so let's call it a return on allocated resources. You've got the resources. What's the value proposition to use them on steam condensate or somewhere else? If I look at what the cost or the lost opportunity of steam, and I look at my labor, and I throw a factor of 50% of my labor costs and materials, those are all things that you can adjust. That one building, if I spend 3.3 hours and I can fix it, I will have saved $148 for that time frame. If I ignore that building, then I'm continuing chopping ahead, wasting energy as I go forward, and as it doesn't get better, it will only get worse because of the temperatures and the way of the problems that are associated with it. My cost is going to increase. Now I've established some real accountability and tracking for managers and crew chiefs. And in the maintenance world, candidly speaking, some of them simply, well, maybe I had a little too much to drink last night. I was out late at a party. I really don't want to go down into that crawl space and fix a trap. So they don't. But if it's been on the list for 9 days and it's cost you $1,000, there's a manager who's going to be asked somewhere, $1,000. That's more than his salary for the week. Why aren't you telling him to go fix it? So it gets up the food chain on accountability and transparency. We can do the same thing on Delta T on chilled water. In one of the buildings, we have a guy that wants to run 300 gallons per minute to serve a small area and part of the stadium, and he comes back with a 1 degree Delta T. Why? You're not cooling the building with 1 degree. You're just pumping a lot of water. I don't expect to reduce the ton hours, but I expect to reduce the amount of water I have to pump, the electricity associated with pumping that water, and with a higher return temperature going back to my production assets that I manage, my efficiency of the chillers will increase because of the return versus supply temperatures that I'm running. So if you go back to that arc, things that I can do in my production area can be entirely set backwards by what we do at the building level. And getting people that are very tried and true, hey, if I pump more water, they're going to be comfortable and it's going to be cool in the building, to understand that, no, that's not the laws of physics. It doesn't work that way. So then when I look at it, we need to visualize, we need to present this. And to give you the concept of quantification of data, that's what we will have in data points per year, Now, who is going to be able to look at that number of meters, those 5 different utilities, and really process that? And the reality is, you can't. The human brain just can look and get blurred on numbers on a spreadsheet. The spreadsheet is color-coded to say, these are the buildings that aren't performing, here's what it's costing you, days on the list. That we can use for prioritization, but we still have a few other people. So key considerations, who am I trying to present information to? What's my target audience for the different visualization I have? What am I trying to convey to them? Steam trap temperature, or steam condensate means you got bad traps. High use means the building's not running efficiency, you're not allocating your work. When do you want to reach the audience? And we're moving into daily reports, 12:01 a.m., in the inbox of the key managers and boots on the ground that are going to go fix the problem so that they can't say, I didn't get the report. Oh, I didn't know that. Oh, I forgot to log in and look at it. So that data that goes to the cloud comes back in the way of a report or some visualization that we have. Where are the people? Where are the people that you're going to present it to, and where are the facilities? We have 200 plus buildings on the main campus. I have other facilities that are far away that I still have to monitor. This platform is not bound by geographical spatial positioning, because I'm taking that data, pushing it to a cloud, so whatever I do in this campus, I could do to one of the other remote campuses that we have, Purdue, Fort Wayne, Northwest. We could put it in there and have it report back. The question is, where is the audience? Who's looking at it? The local level for sure, but maybe our senior executives want to see it too. What are we going to communicate? What's the message we're going to tell you? You have to start customizing that. And how do you get it into a visual? Because people learn more with visuals than straight up numbers. Now, I apologize for this one because we're just not ready to roll it out, and we're not ready to go live and to connect to oops. We created a campus map. The campus map is a standard map put by the university. We show the roads, we show the buildings. Everybody knows what the buildings are. But we also have a little side column that says, here's the buildings, you can click on that. We now start heat mapping that utility to say, this is the intensity of energy use in these buildings. The brighter the red, the more intense. That doesn't mean it's wrong. It just means you're using a lot of energy there. So if I have a high-tech research facility that uses a lot of steam for soil sterilization, heating of greenhouses for the agricultural school, I could be using a lot of energy there. It doesn't mean it's wrong, it just means you got a hell of an intensive use there. But I can easily convert that map into, show me in a heat map index what my steam condensate temperatures are. And now I can take it down to each zone for maintenance and show which zones are really performing well and which zones just aren't giving a shit about our energy use. And I can switch down at the bottom and do steam, condensate, chilled water, electric, and I can total it. Now, we're only going to total steam or condensate. We're not going to do both because you're double counting them. And then separately, we're looking at our water use. As we've started this proof of concept and started using these models and meters that we have out there, we reduced our sewage disposal quantity by 26% over the course of 2 years. And when they start putting in unit prices plus CSO fees, all based upon meter size and minimum flows, that's a pretty substantial reduction to the point where they called up and said, we need to chat, what are you doing? You dropped a tremendous amount of revenue, like $600,000. We expected that to help pay for our bonds. And we warned them at the very beginning, don't go that route because you're going to set the rules. I know those rules, they don't work for a place like Purdue or any other university, and we're going to take action to correct it because I don't want to pay for things that you really shouldn't charge us. And the result is they'll have to go to a rate increase, and guess who they're going to go to the rate increase to? Everybody that's a customer, and the customers beyond Purdue are the staff and faculty of Purdue or the students that live off campus. We're getting into an equitable sharing, but should Purdue pay for offsetting costs of others? A lot of discussion, town gown, warned in advance, got there. So we now have the heat map, and then we can roll it all up, and that we can use at a very high level for senior management or the general public. So this is how I view data utilization. Senior management, I call it glitz, glam, and whiz bang. They want to click one button, have something pop up that they can flip the screen around and show the dean who's asking for more money for his department. Yeah, but you know, the other school, look how good their energy use is. Why are you so far up here that you want more money and yet you're costing me more money? That allocation into their overhead really has an impact on the deans, because if they don't spend it or have it taken away by overhead, they get to keep a certain amount for their department for other things. And again, senior leaders like something that's really easy. Press one button, an icon on the screen, pop it up, simple to navigate thanks to iconic people. We can get there. Physical facilities management. Where are you going to allocate your resources, your manpower? How are you holding them accountable? Those reports really kind of do it. They can still look at the graphic. They can point to the graphic first and then drill down to the individual building level. Energy procurement. And this may sound like it's an outlier, but since we're buying all the raw energy, I want to reduce what we're using out there. So if I can monitor my performance of my buildings, for example, electric, we're in a regulated state. We declare in January our baseload purchasing from the utility company for the full year ahead on an hourly basis. We know we have to buy some real-time power, and we know we can make power, because we can produce up to 40 megawatts. So we're looking at trading off what are the price signals that are most advantageous for us under our contracts that have been grandfathered with the local utility company. But if I know what my demand is at all those buildings, and I can track it real time because we're polling that data every minute or whatever it is, reporting it out in 15 minutes, I can start looking at my building controls and offset when I start my buildings up, when I turn on air handlers and things of that nature. I can take that peak and just chop it down. And I can look at that peak with the data analytics we're doing on baseload, real time, make the power yourself, and figure where we want to move it, where we want to shift that startup or shutdown. I can shut down my chillers a half hour early in order to, and let my temperatures rise at the end of a day. Nobody will notice it, but I can see the results down at the energy level, which means I buy less base load, which means I produce less chilled water, things of that nature. Building level demand reduction. By going into the individual utility, I can look at what that building's consuming and going down to that building and saying, comparatively speaking, this building's very similar to 3 other residential facilities. Why is my demand so high there? And start drilling into specific focus areas on reducing demand at the building level. These are predictive data that you can use as a tool. Staff level maintenance. Guy was out too late last night, doesn't want to do it. Guess what? You don't get to decide what work orders you're going to complete. They get assigned to you. You're tracked. You do it. And if you have a performance evaluation program like most places, all of a sudden it starts showing up you're not getting your work done in the time frame or a reasonable, acceptable level. And then deferred maintenance and planning. We can see if equipment's starting to fail, consume too much power, vibrations, a few other things, we can start saying you need to shift your repair and maintenance or deferred maintenance budget and reallocate it over here. That goes outside our organization and into the people that want to define what the R&R program is, and they're doing it based upon, look at this, we walk around, yeah, it's rusty and the metal pan's rusty, we need to replace this air handler. Not necessarily do this work, fix it up, we save the energy. That money that we don't spend in utilities and the energy and utilities department goes back into the pool where they can reallocate it and spend more on R&R funds. That's our view on the data. And we're customizing all of that. And it's important to know who your audience is. That's the Purdue model for energy and utilities. And I'm done.